Welcome to my channel. So in this video today we will try to know more about Docker and container, and we will try to increase some fundamental knowledge on Docker. So first of all, let us start a container in the most easiest way. So the most easiest way by which you can start a container is Docker run Alpine. Alpine is the base image, and we see the container is created. And if I try to see the container, I cannot see. If I try to see all the containers, also those which are exited, I can see now that the container got exited as soon as it got created. The reason being, I did not start the container with -dit parameter. -d is the detached mode, but if I start the container with -d, which is the detached mode, then only the container will stay up and running. So let us do that. Here I have to give -d, it is for interactive, and I see the container got started. Let me try to see it. Here is the container which is up just now, and the base image is the Alpine from which the container got started. Now I see that there is a command which is /bin/sh. Now from where this command has come, you might ask, because I didn't give any command, I didn't supply any entry point or command while bringing up this container. So from where this command has come? So for that we can inspect this particular Alpine image like this. There will be many lines that will come in the output, but we are more interested in container entry point or CMD, and basically that returns us that the entry point is null, but the CMD you can see /bin/sh. So when you query with docker ps, this value /bin/sh is coming from here. Okay, now we have created a nameless container, and it is time now for creating a named container. So how do I create a named container? I will use the same command docker run, but with an additional --name. What name I will give? I will give a name dipz22 alpine 1. So let me give the name dipz22 alpine 1. So this is the name of the container, and this is the base image Alpine. Let us start this container. You see the container got started, docker ps, and you can see now we have these named containers. Now the previous container was nameless container, so docker gave the name for me, which is some name it will give, arbitrary. It was interesting, Dubinsky, but this one I have supplied the name, so it has given dipz22 alpine 1. Now so I have already shown you that the entry point is null in this container, and also the CMD is /bin/sh, and from there this particular command is coming. But suppose the requirement is that I want to create my own CMD and I want to create my own entry point. So that means I want to customize my CMD and entry point. So is that possible? Yes, that is possible actually, and for that we need to take the help of Docker files, and we will see what are Docker files and how we can make use of them. In the next slide I'm going to show. Here we will customize entry point and CMD by taking help of a Docker file, and we will create our own entry point and CMD. So I'm clearing the screen here, and I am creating a Docker file, and it's a very basic Docker file. So from base image Alpine I will create this particular image, and I have to write the maintainer here, which is my name. Give my email ID also. Okay, so now I will give the entry point over here, which can be something as basic as a shell and -c. So this is the entry point. This is a customized entry point that I'm giving over here, and then the command I will give over here, which is I can give a loop, for example an infinite loop, so that it continues to run inside the container, because if it finishes to run in the if something I give over here, say for example hello world or something, echo hello world or something, so it will finish, then the container will stop. But I want the container to be up and running. For that I need to give an infinite loop, or there can be a lot of ways actually. For example, if it is a Apache web server container, you can give Apache 2ctl -d foreground, so the process is always up. So something which needs to be always alive. For that I will give over here an infinite loop. So let's try to do that. I is equal to 0, and then while true, so this is always true, and do echo $I and sleep for 1 second. Done, and that's it. This is the CMD, or the command of the container. Now I will just save it, come out of this Docker file. So this is what the Docker file looks like. So I will test once whether this particular command is correct or not. I will do it. I will run it in my local, and I see, okay, so I have not increased the counter. So let me increase the counter. So first it is getting instantiated with I is equal to 0. Now when I'm echoing the $I, after that I need to increase the counter plus I, then I make it to sleep for 1 second, and so this one should be all right. Now okay, so this one I will test if this script is working properly or not. 0 1 2 3, yeah, it gives me a proper output. I have tested it in my local. Now let us create a container from this particular Docker file. So the name of the container should be dipz22 alpine 2, and so we will run this command, docker run name dipz22 alpine 2, and the image, okay, sorry, I can't run the container because the image has not yet been built. So first I have to build the image. What should be the name of the image? Let me give dipz22 alpine 2, and the tag let me give v1, and then I can also give the information of the Docker file. So if my Docker file is in some other directory, say xyzpqr, then I can give the Docker file name like this. But in this case my Docker file is located over here, and the name of the Docker file is Docker file, so it is not something else. Therefore I do not have to give this -f, and I only have to give this present working directory, and then it should build the image from the Docker file. Name of the image will be this dipz22 alpine 2 tag, which is v1. So I have built the image, and the image should be there right now. Let me check. This is the image that I built just now. You can see that it got created just now. Now I will create a container out of this image. Docker run name will be dipz22 alpine 2, and then the image itself will be this colon v1. So this should start the container. The container got started. Name of the container is DIPZ22 Alpine 2. So we will now see that I can find the log of this particular Docker container. I can find the log using this command, docker logs -f, the name of the container. This should give me the log. You can see the increment counter, it is getting incremented, and the output is like 1 2 3 4, like that. The output is going on like this, and this is how the output should look. And now I will just do a couple of things, like for example, we know that in this particular Docker file, I'll just clear the screen here. In this particular Docker file, the entry point is bin sh-c and the CMD is this. So basically what that means, there is a order by which the entry point and CMD are executed. It is always the entry point first, and then the CMD gets executed. And so therefore in this case what is happening is, first of all, bin sh-c, and then this particular command is getting executed. We can see this particular command if we do a docker exec and this particular container ID or container name, whatever. If I paste it over here and then I do a ps-ef, and then it will show me that on PID1, which is always reserved for the entry point, this particular command is running. And in this command, this part is the entry point and this part is the CMD. So this is how the container runs. I can also, if I want, I can start and stop the container. So I stop the container like this. The container ID I can give over here. The container will get stopped, and then I can also resume the container one more time. I will show you. Excuse me. So the container got stopped. Now if I try to see docker ps, the container is no more there. Now I start the container. This container ID is gone, so I have to start with the name. The name was DIPZ22 Alpine 2. Actually I could have started with the ID also, because yeah, so this one, so I can start with the ID also. Let me start, and now let me see if the logs have started again or not. Yes, so again the counter has been reset to 0 and this container starts one more time. So this is good. Let me clear the screen. Now I have also checked the process in the container, which is reserved as PID1, because PID1 is always reserved for the entry point command. Okay, so we have seen that. Now let us go to the second scenario, where it so happens that the Docker and the pod comes together now, and they shake their hands, and they come to a decision that, you know, let us work together and let us see how we can work together and do cool stuff. So what happens is, so the Docker and the pod comes together, and the Docker field names are the entry point and CMD, as we already discussed, and the Kubernetes field name are CMD and ARGS. So CMD corresponds to the entry point of the container, while the Kubernetes ARGS corresponds to the command of the container. And we will see how the pod actually influences the entry point and CMD of the Docker, because when the container will reside now inside the pod, then what is going to happen is some of the freedom of the container is going to be taken away. The entry point is going to be influenced by CMD of the Kubernetes. So how it happens, let us discuss this. So we consider scenario 1, wherein we will consider the container DIPZ22 Alpine 2, which is the same container that we created actually. So suppose this particular container is used in a pod and the name of the pod is DIPZ22 Alpine 2, and then we do not supply any CMD or ARGS in the pod. So how it going to behave? So that we are going to see in this case, because we are not supplying any CMD or ARGS in the pod, so the entry point and CMD will take over. And similarly, as we see that the same image, if we take in the same image DIPZ22 Alpine 2 colon version 1, in that same image, the log message should be 1234. We will do that right now. Let me create the pod. Okay, but before creating the pod, let me tell you, because this particular image JPZ Alpine 2 version 1, this is residing in my local, so I need to push it to Docker Hub. Then only the Kubernetes cluster can download from there and then start the pod. So what I will do docker tag this particular image to the repository of my Docker Hub, which is Dipesh M77 /alpine, and let me give a version which can be, for example, 1, and then I will push this particular image. So this is what I'm using. Instead of v1, I'm using 1. So I'm tagging it and then I'm pushing this particular new tagged image to the Docker Hub, and it takes some time to push. Okay, so I have pushed it. Now let me create a pod with this particular container. So let me see if there is any pod already running or not. There is no pod running in this dips22-ns namespace. So let me create a pod with the name DIPZ22 Alpine 2. So this is the name of the pod that I will give, and the image will be this image. Restart never means that it is a pod, and then I can give some labels to it if I want. In this case it will be DIPZ22 Alpine 2. After that, so this is going to be the pod basically. Here I am not supplying any XARGs or CMD for the pod, as you can see. So it's just a very basic pod, and I can actually create this pod. Then if I want to create this pod, I will get rid of the dry run and the YAML this thing, and now this should get created. And k-n, because I have set my kubectl alias as k, so I can write k also. dipz22ns get po, and I can see my pod is running. Now if I take the output of this pod, I can see that the same type of log is getting generated. So that same image I am using here, so I can get the same type of behavior as I was getting in the container. So that particular container is now residing in the pod. Okay, so that's it for the first scenario. Then we move to the second scenario, where now what I'm doing is I am just using a different ARGS. So this, if I am supplying an ARGS, so if you supply only ARGS for container inside pod, entry point of container is used, so the entry point, this one will be used, and CMD is overwritten by ARGS. So this CMD, as I told you, the power of the container decreases when you are providing the value of args. So this will override CMD, and the pod will behave in a new way. So let us see. We will supply a new args in this particular same image. The image that we will be using is the same alpine colon v1 from my repository of Docker Hub. We will see how it works. So I will create run. So this time the name of the pod is dipz22 alpine 3, and the image is the same image that I'm using, not using any different image. So the same image I am using over here. Yeah, this is the same image I'm using. And then restart never to ensure that it's a pod, not a deployment. And I can give labels if I want. Name of the pod will be the name of the app also. Okay, so I can give the args also inside over here. We'll see how it works. So this will be okay, so this will be a different kind of a loop. So while true, which will always get satisfied, and then it will proceed further, do, and then what it is going to do, it is going to shuffle a number from 1 to 10, or say shuffle these three words like, subscribe, share, and it will only have one word in the output, minus n1. So it will shuffle, and then after that it will sleep for 1 second, and then that's it. And then okay, the counter needs to, no, there is no counter over here, so I don't have to increment the counter, and I think that's done. So this is how it should look. I missed something. Oh, I missed this thing. So this is something. So this looks like this. Restart never. Okay, so there is some spelling mistake, I think. Shuff spelling mistake is there. S. Let's see. Okay, now let me check whether this will run or not. I do not want to end up with a buggy pod which will not run. So let me check. So subscribe sometimes. Why is it? Okay, subscribe, like. So it is kind of shuffling these three words. Share, yeah. So okay, this should run. Then that means that I can create this pod now. For me to create the pod, I will remove -o YAML and dry run. So this will create the pod for me. Yeah, the pod got created. Let's see. This is the pod that's created in 7 seconds. It's only 7 seconds old. Let me try to see what is the log that is getting generated. Okay, so it is generating randomly, shuffling those three words as I told you. So what is happening is basically, that means the entry point in this particular pod, if I see in this particular pod, the entry point of the container is getting used, which is /bin/sh-c, in which we have already seen that is the entry point of the image that I am using, and the CMD of the container has got replaced with args. So this scenario we have seen that it is working, and we can actually check this. You can check what is going on inside the pod. exec the name of the pod, which is this, and then do a ps minus ef. That will tell you that this, so this particular is the entry point of the container, and this is the args that I have supplied from while true, this one. So that is this particular scenario where the args of the pod is used and the entry point of the container is being used over here. Going to the third scenario now, where I am going to supply the CMD as well as ARGS. So when you supply the CMD as well as the ARGS inside the pod, then what is going to happen is both the entry point and the CMD of the container is totally ignored. So that means the container loses its power. So the power comes to the CMD and ARGS of the pod. Okay, so we will create a pod with the name DIPZ22 Alpine 4, and we will use the same image over here. Let's do that. And here the log message should be, and this time what I'm going to do, I'm going to use that this particular CMD as, say, it will be like a ping kind of a command, ping and minus I2 and localhost and the args that I will give is another parameter which can be like minus w3600. so for 3600 it will ping, after that it will come out. And this will be the CMD. So we will see whether this takes effect in the pod or not. Let's quickly start creating this particular pod. So here what we need to do is DIPZ22NS in this namespace. I run the name of the pod should be DIPZ22 Alpine 4. Image is the same image. Okay, and labels, okay, restart never to ensure that this is a pod, and then labels can be app is equal to the name of the pod, which is this. Okay, and then yeah, that's it. It should be good enough. And I can give args, basically I can give something like minus w3600. I'm just using this to generate that args thing, and then I will put this in a file and I will customize that file. I will adjust the file. So the file I can give the name as DIPZ22 Alpine 4.yaml. okay, so it gets generated in this file. Let me, okay, I got inside this file. Now what I can do over here, like the args has got generated over here. Similarly, what needs to be generated is the command. The command can get generated like this. So the command is basically nothing but ping minus I to localhost. So it will ping to the localhost with an extra parameter over here, which is going to be, actually I do not need this. I can write it in this way with an extra parameter which is minus w, and I can give 3600 seconds. That looks good. I think we can create this. Very nice. And where is the namespace? Metadata namespace is not there, so I will supply the namespace. Create minus f this particular file name. Let's see if it's getting created or not. Yeah, it got created. Okay, so I want to check the logs of this particular pod, and I see the ping is happening. And if I want to see what is the process running here, I can actually enter this particular pod and check the process. So to enter this, I need to write the name of the pod and do a bash, and I get inside the pod. Sorry, it should be, I think, sh, and then I can, no, there's something wrong. Executable not found. I think something wrong happened with the pod. Let me see. No, it should be fine. But why does it not? Okay, I think the reason being, I think I have to give an interactive mode. Okay, so I can, yeah, now I am inside the pod. Here I can check what is the process running, and you can see the process is ping -i to localhost. This is the, and this is what, this is the command, and this is the args -w3600. So so this is the third scenario where both the CMD and the args are taking effect. Now we will see a situation, or the next scenario, the scenario 4 is a scenario where I will not provide any args, and then I will only provide CMD. And in this case you will see that it will totally override or overpower entry point and CMD. So both entry point and CMD will be completely ignored, and then CMD will take effect. And that does mean that CMD is so powerful it can overwrite the entry point and the CMD of the container. So let me quickly show you that demo where I do that. Basically, I don't have to do much change because this is this particular file is already there. I'm going to copy this file, and then put it in a different name, which is dipzalpine5.yaml. dipzalpine5, sorry, 5.yaml. There I will make the change. Here what I'm going to do is I'm going to change all dipz22 alpine 4. I'm going to change with dipz22 alpine 5. I think that should be it. So the name will be alpine 5 and everything will be alpine 5. The image I'm using the same image. Here I am not supplying any arg, so this one can go actually. Only I need to this, and this is good enough. So I only am having this command. Let us see what happens. So k -dips22n is create -f this file, and this file is okay, and I see this pod gets created. Now let me query whether this pod is there or not. Okay, it's running. Now if I check the log of this pod, yeah, the log is also getting generated. But the interesting thing is, if I see the process, so the process inside this particular pod, ps -ef, ps is fine, and I can see ping -i to localhost. There is no other process. This is the only process, and this is the only, and this is totally overwriting the CMD and the entry point, the original CMD and entry point of the container. So that's why we see that CMD is very powerful, and this is how it is illustrated here. The CMD is the most powerful. So when the container is residing inside the pod, this is how the entry point CMD of the container is getting influenced by the CMD and ARGS of the pod. I think those we have seen all these 4 scenarios right now, and it's time for me to clean up the pods and the containers. Can do that quickly and show you how you can clean up the container and the pod. So first of all, the pod get PO. This is how you generate all the pods, and I want to generate, actually it is pretty easy here. What I can do is delete PO and dips 22 alpine 225, so it will delete all these pods. All the pod got deleted. It's pretty simple. It takes some time. Okay, so it's I will go to another tab here and I will delete the container. So docker ps-a gives me all the container, and here what I can do is grep -b, because I do not need this container column coming or the row. So sorry for that. So these are the containers that are coming, but I only need the container ID. So what I can do is args awk as if the separator is space print $1. Okay, so this is the container IDs of all the containers. Now I want to delete them. What I do is I gather these container IDs and then docker stop all the container IDs, so they will get stopped one by one. Meanwhile, my pod has been deleted here, all the pods, and now I am stopping my container. It takes some time, and then I will also here I'm going to remove the container, but first it should stop here. Okay, they have been stopped, so I remove the container now because they have been stopped. So docker ps-a should not give me any container. Docker images, I can remove them as well. Oh, similarly, I do not want this repository row, and I want to collect only the image ID. Image ID is 1 2 3 on the third column. So what I can do is print $3. Okay, then I collect these IDs and RMI-F and then delete all the images, forced delete. So now docker images should not show me any image. So that's it. I have done the cleanup also. Whatever I have showed to you, I have also cleared all of this. That's it. I think we have come to the end of the lecture, and if you really liked it, please don't forget to subscribe. Thanks for watching, and you have a wonderful day. Bye bye.